Nice to see you all. I'm Dan. I'm an engineer on the team at Hyperlane. Who here knows about Hyperlane already? That's amazing. So you may have heard about Hyperlane in the context of a protocol. Today I want to talk about it in the context of it being an interoperability framework and what you can build on top of it, but also for it, because it spans many VMs and chains, and it's a very kind of like wide encompassing protocol. To set some context, nowadays dApps live on increasingly divergent infrastructure layers or like settlement layers. Sure, you've heard about like monoliths. If you have your dApp live on Ethereum, maybe there's one trade-off space that you're looking to make. Maybe you want access to lots of liquidity and a lot of protocol composability at the cost of high fees. And Solidity. If you want to deploy on Solana, you're going to have lower fees, but you have to learn a new paradigm with managing account state and learning Rust. Some opt for going the app chain route, like Cosmos and Polkadot. Those who want to have control over block production, maybe they want to tweak consensus parameters or transaction inclusion priority. But that still requires you to learn a new, smart contract paradigm. If you want to stay within the Ethereum realm in the EVM and use Solidity, you might build your dApp as a rollup. And you're going to have to do with DA layers and whatnot. But obviously, going on the layer 2, you lose some composability that's inherent on the layer 1. But you do give users lower fees. And then there's even been talk recently about ephemeral chains, those spin up based on demand, just like in Web 2 with cloud computing services and even L3s. But with that, interoperability today is highly fragmented. Say if you're building a rollup, as a developer with your dApp, you have to support several interfaces like deposits and withdrawals from L1 and to L2. Asset bridging, like you have to integrate another provider, most likely, to bridge tokens to other L2s. And that doesn't even touch on general message passing. Like if you have a dApp that lives on several chains and you have a cross-chain DAO and you want to propagate the DAO decisions from one chain to all of your deployments, that falls under general message passing. And I don't think there's too many providers that help with that off the shelf. We've had Aave integrate with us, but with a custom integration. But we're trying to service all of those use cases on as many VMs as possible in chains. If we keep to the rollup world and you look at Caldera, you can go onto their website, and within 5 minutes, it's really just mix and match for a variety of parameters, and you can launch a rollup. You can use the OP stack, pick the native token and the DA layer, and then you have a rollup, and it's up and running. It's probably scalable. It's up to you to, how you, take it further, and if you want to decentralize the sequencer and so on. But you're still kind of secluded. You don't have easy access to liquidity other than via the layer 1. And you have to start playing the BD game. You go to other, bridging providers or L2s, and you set up a roadmap to plan a bridge deployment. And we think this could be different. We view, for instance, if you look at this modular stack, I think interoperability should be part of it intrinsically. Like maybe when you deploy a rollup, you'd also have a bridge deployed by default onto, for all the chains you want to connect to. And this was the original Hyperlane vision, which all of you might already be familiar with. And we're trying to make it clear that Hyperlane is way more than that. Hyperlane really what it does is it separates the transport layer of interoperability from the application layer. So if you think about the layers of the internet OSI stack, you have 4 broad layers, and say your dApp lives at the application layer, ideally you don't want to have to think about the bridging provider you're using or the security they're using. Maybe you want to have it configurable, but not have to deal with all that complexity yourself. So all you have to do is integrate with the Hyperlane smart contracts, and then that abstracts away. Again, if you're talking to an EVM, like to your rollup, and you talk to the layer 2, maybe use the canonical bridge. If you're talking to a Cosmos chain, maybe it's a multisig, but that's all abstracted away from you at the dApp layer. And then, yeah, below the transport layer, there's a bunch of off-chain infra where there's a relayer that's running. There's a key funder that makes sure the relayer has funds so it can keep sending messages cross-chain, and a bunch of other stuff. And obviously, at the lowest level, we're kind of just abstracting away the internet. So we're really trying to provide a consistent interface. You integrate with Hyperlane once, and then your protocol is future-proof to any sort of like bridging models that become available. At a bit of a lower level, say you're on an origin chain, want to send it to a destination. What you do is you call a contract we call the mailbox. You tell it the destination chain, the recipient, and the body can be anything, like a bunch of bytes. It could be an encoding of your choice or whatever. Then there's a relayer that indexes that mailbox and will see, hey, there's a new message going in a certain direction. By the way, the relayer is permissionless. And it will call the destination chain, the mailbox contract on it. And very interestingly, the mailbox will call into the recipient contract, which gets to pick the security module it wants to use to validate like the authenticity and security of the message. So say, again, you're on a Cosmos chain maybe, and your message is incoming from a Cosmos chain. You can use IBC for that and tell the mailbox, just use the IBC security module. You're on an L2 and the message is coming from the L1. The recipient can just say, hey, just use the canonical bridge. And this is kind of the same thing, but visualized more broadly, like across ecosystems. If you're launching something on Cosmos, and IBC is amazing, but you don't want to, be constrained to that, and there's lots of liquidity and users available outside of that. Same with the layer 2. It took you 5 minutes to launch something on Caldera, but you don't want to be isolated. You can pick different security modules. Obviously, this isn't ideal from a security perspective, but we try to take a very pragmatic view where you can launch something from day one, and you don't have to wait for like 2 years to wait for a light client to be developed between, the rollup, the VM that your rollup runs, and then the broader crypto ecosystem. But obviously, making it very easy to select different security modules wouldn't make much sense if you then need to come to us, like Hyperlane, and lobby us to deploy onto your chain. And so to that end, we've invested a lot of time and resources into being fully open source and having great docs to help you deploy Hyperlane and run the infrastructure on your own, should you want to. There's a link to our docs website in there. And I'm actually going to run you through deploying a Hyperlane general message bridge, but also a token bridge. Without actually running commands, because workshop internet tends to be terrible. But what you have to do is basically go to npm and install the Hyperlane CLI. If you've just launched a new chain, you do config create chain, which just asks you for the RPC URL, a name, basically stuff you'd add onto your MetaMask wallet when supporting a new chain. You can specify the ISM, like the security module you want to use, and say if it's a multi-sig, it's going to ask you for the list of signers and the threshold. And then that's all. You're going to have some output JSON files that you're going to be able to use, like with the configurations you just created, and run this deploy command, which is like target chains, the files you just created, and a signer key. And it's going to deploy all the contracts to all the chains you specified. And I'm going to have basically a production ready, or like at least the private key is going to own it for a start. But it's going to, it's going to be a bridge that you can start working with, further decentralized maybe later, ready to go. But now you need like infrastructure to connect those various chains, right? Again, using the artifacts from the earlier commands, you can run Hyperlane deploy Kurtosis agents. And Kurtosis is this cloud infrastructure company that we've partnered with. It will take your JSON artifacts and output a URL. You click on it. You just input a private key to run the relayer and validator with. And you're going to have infrastructure spun up for you just like that. So you don't need to worry about it. And you can start working on your cross-chain dApp, having like the entire bridging layer abstracted away from you. And you can even send a test message with the Hyperlane CLI. Cool. So now you have like general message passing live. Maybe you want to start bridging tokens. And warp routes is our take on token bridging. It's again a collection of contracts that allows you to move like either native tokens, ERC20, ERC721, to foreign chains. And it's basically an abstraction on top of the mailbox contract that I mentioned earlier. And we provide the UI template as well. Takes another 10 minutes to deploy Token Bridge. Again, you run a command to configure the warp route. You deploy the contracts. You clone the warp UI template, pasting the configuration from your earlier deployment, so it knows how to connect to the chain and all of that, and just yarn dev to spin up a local UI, and you have a live token bridge with a nice UI, again ready to go, and to show to your investors and maybe convince them that maybe it's time for them to fund you to build a light client because your kind of app works at the proof of concept level. And since we're at the hackathon, let's also quickly cover the bounties. So you can build at any layer. We tried to keep the bounties as general as possible. So you can build a dApp on top of an existing Hyperlane deployment. You can build a contract like an ISM or tooling for deploying and versioning contracts cross-chain. You can improve off-chain agents like maybe creating a better key funder or tooling for it, or analytics just to track how messages move across chain. One of the bounties is called best permissionless use, and that would involve deploying Hyperlane yourself. An idea is to create a DEX on mainnet that allows you to buy testnet tokens, because some of them are pretty darn hard to get a handle of. So you can deploy a warp route, testnet to mainnet, deploy like either a Uniswap V2 or a fixed price contract for redemption, and then buy, say, from Sepolia to Base, and buy on Base some ETH Sepolia, and then you're able to bridge it back, and you have a bunch of Sepolia ETH. I know the hackathon is very generous and gives you like 1,000 of that, but you get the point. You can also build like a cross-chain key funder, where you have balance on a single chain, but you have like deployments on several chains. And you want to be abstracted away from having to fund all of that because it's an operational nightmare. You can bridge via Hyperlane, then swap on whatever DEX you want. That's available on that VM. Yeah, obviously in the EVM you have Uniswap, but maybe on Solana you have to use Jupiter or something. And you swap there, and then maybe switch to the native gas token of that VM, and there you go. It's all automated, and you just run a service, and it will do the topping up for you. And we also have something called the most creative use of Hyperlane, where we really just want you to, I guess, go crazy. Like, this protocol really spans a lot of layers of complexity and a lot of VMs and a lot of chains. Like, there's many things you could do with it. One of them being like you can register a cross-chain limit order on a Uniswap v4 hook, which you've just seen the workshop of earlier. And you can customize the Hyperlane relayer to scan for prices cross-chain, to find the price limits, and then fulfill it. And then we also have a bounty that's the most generous bounty. It's $4,000 on top of an existing category for the best project, because some of these projects are kind of like big undertakings. So again, you can build anything you want, but should you want more inspiration, scan this QR code and it will take you to a list of our GitHub issues that have a bounty label. Again, some of them are like quite involved, but maybe you can find something that you find interesting. And with that, I'm inviting you to build the modular expansion, and I'll take some questions. If there's no questions, I can keep talking. Okay, I'll tell you a bit about like some other abstractions please raise your hand if you have questions. We have some abstractions on top of the contracts we already provide. One of them, they're kind of inspired by ABC. One of them is called the Interchain Accounts API that allows your contract that you own to have control over an address on foreign chains. And the way it works is via an API contract that's deployed, and again, it lives on top of the mailbox. And it can hold funds, and you can basically use this Interchain Accounts API for the DAO example that I just gave earlier, where you want to run voting somewhere on some chain and then propagate governance changes, or who knows what other use cases. And then there's another API we support. I think both of these are available via the CLI, by the way, like you can deploy them on top of the general message passing bridge. And the Interchain Queries API is basically a round-trip call to read some data from a destination chain at like some contract interface that you probably already know. And once that data is read, the API contract will itself make a call to the Hyperlane mailbox that's like bound back to you, and it will call your contract back with the result of that call. So this is essentially, an asynchronous interface, similar to like how we use the internet today, to read data cross-chain, and probably in the future do write operations cross-chain as well. And Solidity today is built to support only synchronous code, but I think in the future we might be seeing async await hit the Solidity world as well, and start using more and more kind of like Web 2 paradigms we're used to. Yeah?
So a question in that context. So for example, let's say you want to build a very universal Oracle with prices from many dexes, and so you want to grab those prices. You're nodding. It sounds like that would be a good use of that.
Yeah, definitely. Like you can use the Interchain Queries API. Obviously, like you'd probably have to lobby Chainlink to deploy to your chain if it's like a new rollup or something. But if you use the Interchain Query API, you can like bring that data to your chain on demand whenever you need it. So that'd be a great use case actually. And we've had an event with Flare yesterday, and they're basically a layer 1 that's dedicated to, Oracle data. You could use that as well. Cool. Yeah.
When we need to pay the fees, need to be in the origin. We can connect a paymaster on the front. What's the recommendation there?
You mean for paying fees to send a message cross-chain?
Yes.
Mm-hmm. So I said earlier that relaying messages is permissionless. For the bridges that Hyperlane supports, say off the shelf, there's a default relayer that's configured, and you'll have to pay based on a gas oracle. But if you want to relay a message yourself, you could do that for free, right? I mean, you pay the gas out of your own wallet. But normally, the relayer or whoever registers to run as a relayer, they would have to maintain a gas oracle for all the destination chains they support. But you get to pick your relayer actually when you call into the mailbox. So it could be any service provider yourself. Yeah? Very quick.
When you're sending tokens cross-chain, if the token has the contract address different on each chain, how would that work? Would Hyperlane store some sort of mapping from on the source chain and then on the destination say, okay, this user is sending USDC on this chain.
Yes.
Different address, so therefore we need to mint new tokens on this chain.
Yeah, exactly. So there's the warp route contracts basically have counterparts, one that lives on the origin chain and one on the destination, and they're kind of aware of each other. We can talk more outside if you want. That's cool. Thanks for attending, everyone. Happy building.